So today we're going to be looking at 4.5, trapezoids and kites. The lesson objective: I know and can apply properties of trapezoids and kites to find unknown lengths, variables, and angle measures. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So note, a parallelogram had two pairs of parallel sides. A trapezoid only has one pair. An isosceles trapezoid has parallel bases and congruent legs. And so here you can see our bases are parallel, and then our legs are congruent. And then both pairs of base angles are congruent. So again, in the figure to the right, you can see that angle F is congruent to angle J, and that angle G is congruent to angle H. So our base angles are congruent. Additionally, in an isosceles trapezoid, our diagonals are congruent. So in an isosceles trapezoid, we can see that our diagonals are the same length. The midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So the midsegment is this length right here, this VS. And note that the midsegment of a trapezoid is parallel to its base. So it's parallel to our bases, and then its measure is 1/2 the sum of the lengths of the base. So again, the midsegment of a trapezoid is parallel to each of its bases, and its measure is 1/2 the sum of the lengths of the bases. So if this is base 1, and up here we have base 2, the length of the midsegment is going to be base 1 plus base 2 divided by 2. And that is the length of our midsegment there, VS. So here, the measure of angle D, we have an isosceles trapezoid since our legs are congruent. And so that means that our base angles are congruent. So angle D is congruent to angle C. So we know that the measure of angle D is 101 degrees. Now, to find the measure of angle B, we know that we have parallel lines, and we have a transversal cutting through. Looking at the two angles here, we can see that we have consecutive interior angles, which means that we can take 180 minus 101 to get 79 degrees, since our consecutive interior angles are supplementary. Now, JKLM is an isosceles trapezoid. So we know that the measure of angle JML right here is 130 degrees. And we want to know what the measure of angle MJK is. So we want to know what this is. Note again, we have parallel lines. We have our transversal here. And so we have consecutive interior angles. We know that they are supplementary, so we can take 180 minus 130 to get 50 degrees. And then we also have that KN is 6.7 feet and MN is 3.6. So KN is 6.7 and our MN is 3.6. So together we have 10.7 for our M to K, but we're looking for JL. Since we have an isosceles trapezoid, we know that our diagonals are congruent, which means that we can take 3.6 plus 6.7 to get our 10.3 for the length of JL, 10.3 feet. So 4, given DFGH is a trapezoid. So we have a trapezoid with bases DF and GH. So we have our bases, and we know that DF is 5 and GH is 17. we want to find the mid-segment. So we want the mid-segment here. So we're looking for x. On the first page of our notes, we could see that our equation, we take our 5 plus 17, divide it by 2. So we get 22 divided by 2. So we get x equals 11. So that's saying that this length right here is 11. And note that that length is going to be between the two bases. All right, in the figure, MN is the midsegment of the trapezoid FGJK. We want to find the value of x. So here we're given the midsegment and we want to find our other base. So we can take our 20 plus x divided by 2 is going to equal 30. So in other words, we want to add our bases together and get twice our midsegment. So multiplying by 2, we can add our bases to get twice our midsegment. And then subtracting 20, we can get x to be 40. So the length of this base is going to be 40. So again, our midsegment, 30 is between 20 and 40. The length of one base of a trapezoid is 44, and the midsegment is 30, and the other base is 2x plus 12. We want to find the value of x. So again, I'm going to draw my picture. We know that one base is 44, and the other base is 2x plus 12. And then it tells us that our midsegment is 30. So again, I can set up my equation. I want to take 44 plus 2x plus 12 divided by 2 has to equal the length of my midsegment, which is 30. So then I can combine my 44 and my 12 to get 56 plus 2x should equal 60. Subtract my 56, I get 2x equals 4. Divided by 2, I get x to be 2. So make sure you know how to find the length of the midsegment and given both bases, or if one of the bases given a midsegment and a base. Next, we are going to talk about a kite. So a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So you can see that they are next to each other. So PS is congruent to SR, and then PQ is congruent to RQ. So in a kite, only one pair of opposite angles are congruent. So note in a parallelogram, both pairs of opposites angles were congruent. In a kite, only one pair. So note just one. So here you can see in our picture, angle J is congruent to angle L. And the angles that are congruent to each other are always the ones that are between the sides that are not the same. So you can see that JK is not the same length as JM. And it's that angle that is congruent to the one opposite that. So in a kite, the diagonals are perpendicular. And note that the diagonal between the non-congruent angles bisects that pair of angles. So that's saying that since we have B and D are our congruent angles here, the diagonal that does not connect those angles bisects the other two angles. So you can see that angle C is bisected, and then angle A as well is bisected. But note that angle A is not necessarily congruent to angle C. Come in and ask questions if any of those confuse you, and we can work our way through them. So number 7, we have WXYZ is a kite, and we want to find the measure of angle XYZ. So XYZ, we're looking for this right here. We know that angle X is congruent to angle Z, since those are our non-vertex angles, the ones that are between the sides that are not congruent. So we know that angle Z is 121 degrees. Since a kite has 4 sides, we know that the sum of the angles has to be 360. So we can take 121 plus 121 plus 73 to give us 315. and then subtract that from 360 to get 45 degrees. So we get that the measure of angle Y there is 45 degrees. So note, if you're having issues seeing which angles are congruent, you can rotate your paper so that the kite is sitting upright the way that you would think, and then you can easily see which angles are congruent. Over here, we have the angle MNPQ is a kite. We want to find the length of NP. So we want this length right here. We know that NR is 6, and then we know that these angles are congruent, which means that this diagonal is bisected, and so that this length is also 8. So we can take the square root of 6 squared plus 8 squared, and typing that into our calculators, we'll get that to be 10. So the length of NP is 10. So again, we just used the Pythagorean theorem there, since we knew that we had a perpendicular angle there, that the diagonals are perpendicular in a kite. So FGHJ is a kite. We want to find the measure of angle GFJ. So we want this measure right here, but we know that these two angles are congruent, so we can take 360 and subtract our 128, subtract our 72, and we're going to get 160, but then we have to divide that by 2 because we know then that angle F plus angle H has to be 160, but they have to be the same. So dividing that by 2, we can get that it is 80 degrees. Over here, now you can see that again, we have a kite, and note that the kite is laying on its side. So if you need to turn your computer or paper, please do so. But we have a kite, and we want to find the length of ZY. So again, we know that our diagonals are perpendicular, so we have a right angle. So we can take the square root of 24 squared plus 8 squared, and that's going to give us the square root of 640, which you can simplify to 8 square root of 10, or in decimal form, 25.3. Thank you for watching. Please rewind, watch this again, pause it, make sure you're getting all the notes, and come in for questions. Good luck!